Hi guys, it's Miss Leslie and I'm coming to you with a video on the motion rules for translations to make sure that we're understanding how to go about completing the next lesson. So guys, the last video that we did, we talked about what each one of our transformations was. We talked about what a rotation was, what a reflection was, and what a translation was. And we're going to review them again very briefly, and then we're going to talk about and we're going to look at an example of how those rules work. And then we're going to talk about the motion rules that you're going to need to apply to be successful on the next lesson. So guys, the first translation rule was a rotation. Remember that a rotation is a 90-degree movement around the origin. And whenever you're moving in a rotation, you always move counterclockwise or the opposite of a clock. So guys, let's look at an example over here of a rotation. So everybody sees that I've got my rectangle and it's on the coordinate plane. And guys, see I've got my little dot over here in the corner. That's to show that this point right here is going to stay kind of still, but the rest of the rectangle is going to move. But this point is just going to rotate around the origin or at the coordinates 0, 0. Okay? So we know that each quadrant is 90-degree movement, and this is the direction that we move in, opposite the clock. Okay? So a 90-degree rotation looks like this. Okay? I only moved from this quadrant to this quadrant, but look what happened. The rectangle was laying down and now it's kind of standing up. So that's a 90-degree rotation. Then 180 degrees looks like this. See? It moved from here to here to here. So it moved twice because that's two 90-degree rotations. Then 270 degrees, the point's going to stay still, but we'll move the rest of it like this. Okay? See how this vertex is just moving around the origin? And then 360 degrees means it should be back where it began. Okay? So that's what a rotation kind of looks like. And we're going to talk about the motion rules for rotations in just a minute. Okay? Guys, please remember what a reflection is. A reflection is a mirror image over the x-axis or the y-axis. Remember that each of your axes acts like a mirror. So if the y-axis is the mirror, then that means that this rectangle is going to see its image on this side because the y-axis is the mirror, so he sees himself over here. Same thing for a reflection across the x-axis. If this is where the rectangle is and the x-axis is the mirror, then that means it's going to see himself right here on this side. Okay? Guys, the last type of transformation is a translation. And remember, guys, that a translation is the only transformation that does not change its orientation. So what's going to happen is this rectangle just slides. This would be up and down. See, guys, how it would be moving up and down against the y-axis. This would be left and right. So it would be moving left and right along the x-axis. So it's just a slide, but the rectangle never turns, which means it does not change its orientation. So guys, we have to talk about the motion rules to make sure that you're going to be successful on these next couple of lessons that have to deal with transformations, because each one of these rules has its own, each one of these transformations has its own rule. So we're going to look at each motion rule and then apply each motion rule according to what the motion rule says. Okay? First one that I want to do is a translation. Okay? And guys, I can't remember what the exact motion rule is for translations, but I am sure about one thing. How you go about reading any translation rule is that you have your coordinate x, y that lies on your coordinate plane, and you read the arrow goes to. So what it says is x, y goes to x, y. And guys, underneath x, I've got arrows for left and right, because if you move your x coordinate, you can either move left or right because the x-axis runs left or right. And then for the y, I've got an up arrow or a down arrow, because you guys know that when you're talking about traveling on the y-axis, you either go up or you go down. Okay? So guys, I've got this little image over here on the coordinate plane, and I've named the coordinates for it. This little line right here has a name. This first coordinate is at +2, +2. You guys see I went over 2 on the x-axis and up 2 on the y-axis to get this coordinate. Same thing for 4, 4. Went over 4 from the origin on the x-axis, up 4 on the y-axis, and there's my point. And what we're going to do is we're going to translate this by moving it 1 unit to the right and 2 units up. Okay? So guys, what we need to do, if we're going to move this coordinate 1 unit to the right and 2 units up, is that we apply the motion rule by doing what it says. How can you move this point 1 unit to the right? Well, you would just do that. You can either add 1 to your x coordinate, or you can just move 1 unit to the right. And then we're supposed to take the same coordinate and now move it 2 units up. So I'm going up 2 on the y-axis. 1, 2. So when my point used to be here, it is now here. Now let's take this point and move it. 1 unit to the right, 2 units up. So where my coordinate used to be at 2, 2 and 4, 4, they are now at 3, 4 and 5, 6 by applying the translation rule. Okay? Because remember, guys, that translation is just a slide. Notice, guys, that it did not change its orientation. I just did what the translation rule asked me to do. Moved it 1 unit to the right and then 2 units up. 1 unit, then this point, 1 unit to the right and 2 units up. Yes, guys, you need to apply your translation rule to all of your points in order to be successful in having a translation or a slide. Okay? All right. Guys, let's look back over here at the next type of transformation. The next type of transformations are rotations. And to me, these are the hardest because they've got the most rules and the most rules that you have to apply. So, guys, remember that you have 4 types of rotations around the origin. You can either move it 90 degrees, 180 degrees, 270 degrees, or 360 degrees. Okay? So guys, in each one of these rules, what you have to remember is what XY goes to. So guys, this will be a good time for you to take a picture or to write these rules down, depending on how many times you're supposed to move your image around the origin. So a 90-degree rotation, its rule is XY goes to the opposite of X and Y stays the same. Okay? A 180-degree rotation would be XY goes to the opposite of Y, the opposite of X, and that's where your new coordinates would be. Then for a 270-degree rotation, it would be XY goes to X, and then the opposite of Y. And then 360-degree rotation would be that XY was going to stay where it was. It went all the way around, and it's going to go back to XY. And I know, guys, these don't sound very familiar to you, so I'm going to show you what a 180-degree rotation should look like. So, guys, what we need to make sure that we remember is that a 180-degree rotation, it's the rule XY goes to the opposite of Y, the opposite of X. Let me show you guys how to apply the motion rule. Okay, so I've got this little line right here, and I want to rotate it 180 degrees. So what we need to do is find all the points for this line. This point right here is at 2, 3, and this point is at 6, 3. So guys, what we're going to do is take our point XY, 2, 3, and we're going to change it to the opposite of Y, the opposite of X. So guys, where X used to be is now where Y is going to be, and where Y used to be is now where X is going to be. So they actually swap places. So 2, 3 goes to 3, 2. And what else does the motion rule say? We're supposed to take the opposites of them. So these were both positives. They're going to be changed to negatives. Same thing for 6, 3. First thing we're supposed to do is take them and flip them. So what used to be Y will become X. And then we're supposed to take the opposites of them. So they were both positive. We changed them to negatives. Let's apply the motion rules by graphing these points to see where we're going to end up. Let's graph -3, -2, and find out where our new image will be. So -3, -2, and -3, -6, -3, -6. So guys, what you have to imagine is that if this line traveled around the origin, this point is what's staying still, and it's just moving. So it used to be in the first quadrant, it is now in the third quadrant after having an 180-degree rotation. Okay? Guys, the last type of transformation is a reflection. Okay? The rules or the motion rules for reflections are simple. If you're reflecting across the y-axis, what happens for the motion rule is that xy goes to the opposite of x, y. If you're reflecting across the x-axis, what happens is the motion rule is xy goes to x, the opposite of y. So guys, here's our last image. You see it's another little line. What we need to do is name the coordinates. This coordinate is -5, 1. And this coordinate is -5, 5. And we're going to reflect this image across the y-axis. So remember our rule is that xy goes to negative opposite of x, y. Okay? So let's take our coordinates and apply the rule. Instead of having our coordinate be -5, 1, I'm supposed to take my x coordinate and change it to its opposite. So the opposite of x would be +5, 1. And then we'll do the same to this coordinate here. We're going to take the opposite of our x coordinate, which would be +5, 5. And then our image will be reflected across the y-axis. So let's find 5, 1 over 5 and up 1. And then 5, 5 over 5 and up 5. So guys, notice that when you have your mirror image, remember that the y-axis is going to act as the mirror and see how the image sees itself. Okay? So guys, listen, if you're having difficulty with this, I plan to do another video about one of these hard problems. But what you need to do is make sure that you know these motion rules and know how to apply them. When it tells you that you take y and x and they're the opposites of each other, flip them and then make them positive or make them negative. You read this the opposite of. So guys, what you need to make sure that you do is apply the motion rules correctly, and then I'll do another hard problem for you tomorrow night. As always, guys, if you have any questions, just let me know. Text me, call me, or send me a message through Odyssey Wear. Have a good night.